Hey everyone, here's our math problem for today. Find the value of x given this equation, 3 raised to x plus x equals 30. This is a kind of problem where the variable is found both as an exponent and as a base. And one way to solve this kind of problem is to use what we call as the Lambert W function. You can pause the video and see if you can solve this math problem. Now let's solve this problem together. Let's begin by rearranging the order of the terms. Let's write this as 3x equals 30 minus x. We subtract x from both sides of the equation. Then let's divide both sides of the equation by 3 raised to x so that the left side becomes 1 and we just copy the right side. Now let's interchange the order so that 1 is at the right side of the equation. Then let's recall this property. When you have 1 over 3 raised to x, that is just the same as writing that as 3 raised to the negative of the exponent of the denominator. This means that this resulting equation can be re-expressed this way. We copy the numerator and multiply it by 3 raised to negative x and copy the right side. Now, our goal is to come up with a form similar to a times the natural number e raised to the same number as this a. So we want this a and this a to be the same. What we have here is 30 minus x and 3 minus x. So they are not the same yet. So what we can do is we can multiply both sides of the equation by a constant 3 raised to 30, do that also for the right side. The purpose is when you multiply 3 raised to negative x times 3 raised to 30, we can now apply the property of exponent that says when the exponential numbers are multiplied and their bases are the same, you copy the common base and you add the exponent negative x plus 30 or 30 minus x. So we now have here 30 minus x and you have here 30 minus x. Our problem is we need the natural number e, but what we have here is 3. So we need to be able to introduce the natural number e in this equation. How can we do that? Let's recall that e raised to ln of x is just the same as x, because e and ln are inverse operations that can cancel each other's effect. So the resulting value here is simply whatever is the input x. That means if we have e raised to ln of 3 raised to 30 minus x, this is just the same as whatever is this input 3 raised to 30 minus x, which is what we have here. So we can therefore replace this part by e raised to ln times 3 raised to 30 minus x, and here is now the result. This part here is replaced by this expression. So you have 30 minus x here, you have 30 minus x here, you have e, but there are extra expressions ln and 3. We want only this natural number e. So how can we further simplify this? What we can do is, let's recall the property of logarithm that says the ln of a raised to m is just the same as that exponent m times ln of a. That means if you look at this part here, we can simplify this by appending 30 minus x to the front of ln and copy ln 3, and here is the result. This 30 minus x is now here, this ln is here, and this 3 is here. So we have 30 minus x times ln 3, we have here 30 minus x. Again, this is not yet the form a times e raised to a, because there is an extra ln 3 here. So what are we going to do? If there is no ln 3, then let's introduce that factor by multiplying both sides of the equation by ln 3. So we multiply the left side by ln 3, we multiply the right side by ln 3, and we simplify. Notice now that this part is just the same as the exponent. So you can now think of this as your a, and this is your a also. They are the same. So we now have the form a times e raised to a, which is exactly this part. And based on the Lambert W function, the Lambert W of the quantity a times e raised to a is simply a. Whatever is a, that is the value of this Lambert W function. So, if we take Lambert W of both sides, this left side would just be our a. And our a is 30 minus x times ln 3. So this is now our a after applying the Lambert W function at the left side here. And we take also the Lambert W of the right side. So the right side is just a constant, and the variable x is now isolated and we are near our solution. So that we can have a form a times e raised to a also here, we can split this 30 raised to 30 as 3 raised to 27 times 3 to the third, because this 3 to the third is 27. And if we rearrange the order of the factors at the right side, we can write this as 27 times ln 3 times 3 raised to 27. So our goal is to arrive also at this form. We need to introduce also the natural number e. And how do we do that? Let's recall again that e raised to ln of x is equal to x. This time, 3 raised to 27 is just written as e raised to ln of the same number, 3 raised to 27. So that means this part here can be replaced by this expression. So this part becomes now this expression. Now, you have here again another exponent that we can append to the front of ln using properties of logarithm. So this is now the result. And let's investigate. This is our a, 27 ln 3, and this is also our a, 27 ln 3. So this form here is exactly a times e raised to a, where our a is 27 ln 3. And we take the Lambert W function of that expression, which is just equal to a. So the right side, therefore, is just 27 times ln 3, and we just copy the left side. Notice also that ln 3 and ln 3 are common factors, so we divide both sides by ln of 3, and the result now is simply 30 minus x at the left side and 27 at the right side. This is now cancelled out, and this is also cancelled out. And then solving now for x, we add x and subtract 27 from both sides of the equation to arrive at x equals 3. And to check if our answer is correct, we substitute 3 to the variable x. So we have 3 to the third plus 3 equals 30, and 3 cubed is 27 plus 3 is indeed equal to 30. And it's verified that our answer is correct. Thank you very much.